Do-do-do-do. Welcome everyone. It's good to see you again. How have you been? Da-da-da-da, ba-da-da-da. All right, we're going to continue solving the problem the tortoise versus hare, right? In the last Friday. Okay, remember, according for that situation, we have the following data. The problem mentioned that tortoise runs at a velocity of 0.10 meters per second. Meanwhile, the rabbit or the hare in this situation it can run 20 times faster than the tortoise. For that reason, if you multiply 0.10 times 20, that will be 2 meters per second. The problem mentioned the tortoise win the race by its shell that's supposed to be a length of 20 centimeters or 0.20 meters. Meanwhile, the rabbit or hare, she's lying down or resting around 120 seconds, I mean 2 minutes. So the question in that situation was, what will be the total time of the race and what will be the distance that they're supposed to cover? All right. In the last class, I explained you already, it doesn't matter who is faster or slower. In this situation, the distance that's supposed to cover the turtle, that will be the same distance that the hare that's supposed to cover because we are talking about a race. Okay, that's a simple, merely words. It doesn't matter who's faster, who's slower. And remember, because in both situations, the turtle and the hare moves at constant speed, remember the definition for distance. Distance, that will be the product between velocity multiplied by time. This is the concept or the genetic formula that we have to use in this situation. But sometimes this formula will have to be mutated depending what are the conditions. For example, in the distance lateral, we can follow the formula velocity distance equals velocity times time. But you're going to ask why I'm adding these 20 centimeters or 0.20 meters. Well, and adding because it's a part of the distance that contributes the turtle wins the race. This is a distance that represents the advantage from the total. For that reason, this original formula, instead to write the distance and replace it by velocity and time, and adding that 20 centimeters of the shell of the turtle that contributes to win the race. That's why we are adding this situation. How about the hare or rabbit? The concept is the same. Distance is equals velocity times time. Velocity of the hare multiplying by the time of the hare. But why is the mutation? Why I'm subtracting 120 seconds? Because he's lying down in a tree. I don't know where it is, but he's wasting her time, his time, and I was talking about 120 seconds. And because he's wasting time, that's why we are subtracting because it's a waste, it's a disadvantage for the hair. For that reason, in the variable t, I'm subtracting 120 seconds because it's a delay time. For that given merely words, the concept distance equals velocity of time we are maintained. What were the change? The change were in the total, we are adding the 20 centimeters of the shell, and in the rabbit, we are subtracting in the period of time 120 because it's a delay time. Okay, now what we're going to do, replace the formula. Velocity of the turtle, 0.10 meters per second t, plus 0.20 meters that represents the distance of the shell equals the velocity of the hare is 2 meters per second. Remember, 20 times faster than the total. And we're going to apply distributive property. the quantity of t minus the 2 minutes, that's the delay time, or 120 seconds. What we have to do? Well, copy this expression once again, and we're going to apply distributive property. I mean, 2 meters per second t, 2 meters per second t, negative 2 times 120, that will be 240 minutes. Now, what do we have? We have a simple linear equation. We can regroup the variables in one side and the numbers in another one. If you wish, we can regroup the letter T in the left side and the number right side, or vice versa. At the end, it's the same. Okay, so what I'm going to do, I'm going to regroup the letters over here, 0.10 meters per second T, subtracting 2 meters per second T, that will be equal to negative 240 meters. And because 0.20 is adding, passes to subtracting. Okay, we have like terms. 0.10 minus 2, that will be negative 1.9 meters per second t equals negative 240.20 meters. And because we are looking for the period of time, remember this negative 1.9 is multiplying, passes to divide. I'm going to use the green marker because we have another problem over here. And I don't want to confuse this one. For that reason, we can divide.
Can you explain why you did the last one?
Why what?
Why you did the, like, can you explain the last part? I didn't understand.
In what part? In which part? In which one?
Where you regroup the
Ah, we have the linear equation over here. And remember, we have in onto this part you're talking about.
yes.
Okay, remember we have to use solve for t. Well, if you see 2 meters per second is positive, when you move to the left side, that will be negative. Okay, and this 0.20 meters was positive. When you move to the right side, was negative. We're negative. Okay, so 0.10 minus 2, that will be negative 1.9 meters per second because we have like terms. Same way over here, negative 240 minus 0.20, we have negative 240.20. Understood?
Yes. No.
Okay.
No.
Okay, then. Now we're going to divide. I'm sorry. I'm going to divide this quantity, 200.
But how did you subtract from 2 meter per seconds and 120 seconds? Like,
No, I cannot. I cannot just starting 120 seconds in 2 meters. I'm multiplying. I'm
okay.
multiplying. If you see, 2 times 120 is 240. And if you see the unit for seconds, I'm canceled because this is divide, this is multiply, and the result is meters.
Okay.
I cannot remember. I cannot subtract variable with a number. Variables with variables and numbers with numbers. For that
Okay.
reason, all right, my pleasure.
Thank you,
240,
Mister.
my pleasure. Don't worry about it. If you have doubts, questions, you're free to do it. Don't be shy. Divided by 1.9. So the first answer will be 126, 126.42 seconds. Why seconds? Because at the moment that I'm going to divide meters divided by meters per second, the unit meters with this unit meters will cancel and we have seconds. All right. And negative times negative, that will be positive. Okay. We have the first answer. How long will take or delay this race? Well, 126.42 seconds. And what will be the distance? Well, simple. Because they're asking for what will be the distance, we have this formula, right? Distance equals velocity times time. Remember, it doesn't matter if you're using the formula for distance or the total or the hair. At the end, the distance will be the same because it's a race, okay? So which one formula would you like to use? Turtle or rabbit? On which one? It's up to you. ¿Cuál le gustaría que usemos? ¿La distancia de la tortuga o del conejo? Sin importar cuál elija, la respuesta va a ser la misma porque estamos hablando de la misma carrera. Ujú.
The
Okay.
turtles.
The total, okay. Distance of the total. Remember, the formula for the distance of the total equal velocity of the total, period time, plus 0.20 meters. Okay, this is the formula from the distance of the total. Now I'm going to replace this one. The distance of the total or total distance, you know, is the same, will be 0.10 meters per second. And instead to write the variable t, I'm going to replace by parentheses 126.42 seconds, close parentheses, and adding 0.20 meters. Okay? Oh, I'm going to move. Just hold on. I'm going to move to the... ¡Ay, qué bonito esto usted! Es lo que me gusta, que se puede mover.
Fíjese que tengo
Ajá,
un problema.
dígame.
En la calculadora, o sea, estoy multiplicando, dividiendo y no me sale como me debería de salir, porque sale una cosa arriba que dice SSI, no sé si es que lo tengo diferente.
Ah, SSI, eso quiere decir que usted lo tiene configurado en Scientific Notation. Tiene que ponerlo en normal. ¿Qué calculadora tiene usted? ¿La gris
La
o
gris.
la que yo estaba enseñando en la mañana?
No exactamente el mismo modelo, pero sí se parece bastante.
Ok, entonces, mire, si es más o menos parecido, pero le aparece esa parte que dice Mode y le aparecía todo el menú.
Sí,
Ok, entonces, mire, haga lo siguiente. Como usted lo tenía, lo tiene en Scientific Notation, haga lo siguiente. ¿Tiene una tecla Shift?
sí,
Ok, presione Shift, Mode.
ya.
Ajá. Me imagino que en todas esas opciones creo que le aparece una que dice Norm, de normal, NORM.
Sí, sí, me sale.
Ok, ¿qué número le sale?
8.
Presione 8. Entonces ahí le va a preguntar si quiere normal 1 o 2. Presione el 1.
Ya, mister,
Ya.
gracias.
Hoy sí ya debería quedarle check. Dele, dele, no hay problema. Okay, let's going to conclude the problem. 0.10, 0.10, parentheses, 126.42, close parentheses, add 0.20. The answer will be 12.84, 12.84 meters. So the total distance of the race of the total, it doesn't matter what I'm going to choose at the end, it's the same. 12.84 minutes.
Mister,
Uh-huh.
I have a question. How
Yeah.
did you get the 1.26? I mean,
No, 100.
126.42.
The answer for this equation, the green one,
Yes.
is the
Yeah.
green one. The only thing that I have to do is replace. And we have the solution of the problem. Okay?
Replace what?
Sí, o sea, reemplace la T por esta respuesta que tenemos en verde, que fue 126.42. Y ahí solo multiplica y suma. Okay? All right, guys. Now we're going to
Mister?
study. Uh-huh.
No, but like, how did you get 126.42 seconds?
Okay. Can you see we have negative 240.20 meters, right? And negative 1.9 meters per second is multiplying t, because this quantity is multiplying, has to divide. Divide this quantity divided by negative 1.9, and you got that answer.
Okay.
My
Thank you.
pleasure. My pleasure. Ta-ta-ta-ta-ta-da. Okay then. So now we're going to talking about a unit for acceleration. Remember this equation, you have this already. And just copy it once again over here. because it's a little review according to the equations. But this formula you got, copy this one. In this kind of problems, it's easier to identify uniform acceleration versus uniform speed because the most of the time you're going to see there's going to be a change of the velocity. Remember, df represents final velocity, di represents initial velocity, t represents time, d represents distance, and a represents acceleration. Remember, acceleration is the change of velocity divided by time. So if you read the first problem, this lesson says a truck covers 40 meters. 40 meters, what data is this? Okay, 40 meters is a distance. Remember the unit of that distance is meters or feet. Okay, distance 40 meters. Okay, in 8.5 seconds. Obviously, this is the period of time. 8.5 seconds. Continue. While uniformly slowing down to a final speed of 2.8 meters per second. Final speed, because the problem mentioned final speed, BF, final velocity, final speed, 2.8 meters per second. And we have two questions. Find the truck's original speed, obviously, the initial speed of velocity, and find its acceleration. Okay, guys. As soon as you can see, it's too easy. Identify when we're talking about uniform acceleration than uniform speed. How we can proceed these situations. This is like a menu in the restaurant. You have 4 different formulas, okay? And according to the data, you have to choose one of these formulas that will be useful to trying to looking for what is they're asking for. For in this situation, if you see, we have distance, we have time, we have final velocity, and we are looking for initial velocity and acceleration. Obviously, we have to find out one data, and after that, another one. So guys, we have 4 formulas. Okay, what will be the chosen one, the PETS formula that we can choose to find the initial velocity? What do you think? Remember, we have the distance, we have the time, and we have the final velocity. In these 4 equations, what will be the better one or the chosen one to use and find out the initial velocity? What do you think?
Distance, I think.
Uh-huh. Distance equals?
40 meters.
Okay, just tell me what will be the equation that we're supposed to use. The first one, second one, third one, or fourth one. Because we have to choose one formula. Uh-huh. Tell me, what do you think? ¿Qué ecuación sería la más apropiada si sabemos que tenemos distancia, tenemos tiempo y tenemos velocidad final? Y ahorita nos piden la velocidad inicial. ¿Cuál de las 4 sería la más apropiada?
La tercera.
Okay, what happened if we choose the third one? We know the final velocity? Yes. We know the initial velocity? No. We know the acceleration? No. We know the time? Yes. So if you choose the third formula, we have serious problem because we have 2 unknown variables. Yeah, and there's a young lady, she want to say that, another thing?
Yeah, what is the name of the second one?
Distance equals 1/2 acceleration times square plus initial velocity in time. The first one and second one are using for find out distance. The third one and the fourth one using by finding final velocity. Okay, and the entire name of this equation is equation of uniform acceleration. Okay, so remember, choose one singular equation that we supposed to have one singular variable. My advice, we can choose the first
First
one.
one.
The first one. This is the big, this is the how to say that? This is the greater thing, and this is the situation. Identify what equation has one singular variable. For example, this case we have distance equals final velocity plus initial velocity divided by 2, multiplying by the time. Now, let's going to replace, instead to write distance, remember, that will be 40 meters equals, open parenthesis, final velocity 2.8 meters per second plus, what is the value initial velocity? No idea. So we're going to write initial velocity divided by 2, close parenthesis, and instead to write time, the time is 8.5 seconds. If you see, 8.5 seconds. And before to solve BI, this 8.5 seconds can be divided by 2 perfectly well, because we have a parenthesis. For that reason, we can apply that division. Okay, so let's going to divide 8.5 divided by 2. The answer will be 4.25. So we can copy once again 40 minutes, open parenthesis, on a smaller parenthesis because we don't have the fraction anymore. We're going to apply 2.8 meters per second plus initial velocity, and instead to write 8.5, remember we divide 8.5 divided by 2, and the answer was 4.25 seconds. Okay, and because this quantity is multiplying, passes to divide. I mean 40 minutes divided by 4.25 seconds equals, you don't need any more the parenthesis because there's nothing, we can multiply this situation. So we can write only 2.8 meters per second plus initial velocity. Multiply passes to divide. Divide these two quantities. 40 divided by 4.25, and the answer will be 9.41. 9.41. 41 meters per second equals 2.8 meters per second plus initial velocity. Okay? And because we are looking for the initial velocity, if you see 2.8 is adding, passes to subtracting. So we can conclude that initial velocity will be equal the subtraction between 9.41 minus 2.8. 9.41 minus 2.8. For that reason, the answer will be 6.61 meters per second. And that's it. We conclude the first question. What is the truck original speed? 6.61 meters per second. Questions on the dashboard?
Mister,
Mhm.
why did you divide 4.25 by 2?
No, no, no,
Oh,
no.
8.5. 8.5 by 2, why did you divide it?
Because if you see, there's a multiplication parenthesis, and there's no number who's adding or subtracting the number 2. So in mathematical process, we can divide this situation just for reduce the fraction and we got whole numbers, but you perfectly well to do it. But if you don't want to do that, there's a lot of things that we have to do. One of them, if you wish, but that will be a little bit complicated, this number to divide passes to multiply. Okay, we got 80 equals 2.8 meters per second plus VI, and 8.5. Let's multiply, passes to divide, and we got the same answer, 9.41. Okay, if you wish, we can divide first, or the number 2 passes to multiply and divide after that, 8.5. Okay, got it?
Thank you.
My pleasure. But it doesn't matter in which way we're going to obtain that one. At the end, the result will be the same. I'm going to prove it. I don't know if you can see the calculator. Ahí empiezo otra vez. If you see 40 times 2, you know that will be 80, right? 80 divided by 8.5. If you see, we have a fraction, okay? Push the button SD. If you see, we have 9.41. And if we subtract 9.41 minus 2.8, 9.41 minus 2.8, the result, we have fraction over here, push the button SD, we have 6.61. Okay? This is the beauty of the math. It doesn't matter which technique you're going to choose. At the end, the result will be the same. Now, the second question. Find its acceleration. Because, my dear students, we know the distance. We know the time. We know the final velocity. We know the initial velocity. And the problem asking for what will be the acceleration. We can choose, if you wish, the second formula. If you wish, we can choose the third formula, or if you wish, the final formula or the fourth equation. Why? Because if we analyze the second equation, we know the distance, we know the time, and we know the initial velocity. Only we have to solve for acceleration. If we analyze the third one, we know the final velocity, we know the initial velocity, we know the time, only missing the acceleration. And the fourth one, we know the final velocity, initial velocity, the distance, and solve for the acceleration.
I think the third one would be the easier one.
Yeah, exactly. This is what I'm going to tell you. In this case, choose the easier one. And that will be the third one. Perfect. As soon as you can see, final velocity equals initial velocity. Oh, sorry. Initial velocity plus acceleration and time. Okay, before to solve this problem, remember the concept. What is the acceleration? I told you already the acceleration is the change of the velocity divided by the period of time. And I explained you, when we are increasing the velocity, see your initial velocity was smaller and we're going to increase that velocity, the value of the acceleration will be positive. Okay, but I explained you already at the beginning of the problem. We have a highest value of the velocity, and this velocity is decreased. The acceleration must be negative because we're talking about a deceleration in physics terms. In simple common language in English, this is a brake in the car, simple merely words. For that reason, if we are doing well that problem, this acceleration, that's supposed to give us a negative answer. Why? Because the initial velocity is 6.61 meters per second and the final velocity is 2.8 meters per second. As soon as you can see, the velocity was decreased. So we're supposed to have a deceleration. This is the physics concept. Well, let's going to prove that in math. Just replace the values. Final velocity, 2.8 meters per second. Initial velocity, 6.61 meters per second. Plus acceleration, no idea what is the value, but the period of time is 8.5 seconds. Okay? 6.61 is adding, passes to subtracting. If you see, 2.8 meters per second, subtracting 6.61 meters per second equals acceleration multiplying by 8.5 seconds. Okay, let's going to subtract 2.8 minus 6.61, and the result will be negative 3.81. Negative 3.81 meters per second equals acceleration, parentheses, 8.5 seconds. Because 8.5
Miss,
is
can you repeat what
multiplying,
you did there?
excuse me,
Can you repeat what you did there?
again, sorry, I can hear you. Again,
Can you repeat what you did in the last step?
in what step?
2.8.
Okay, we have to subtract 2.8 minus 6.61. Okay, déjeme ver. 3.80, 3.81. Negative 3.81, sorry. Negative 3.81. Sorry. That was your question, I guess.
Yes, yes.
Okay, sorry. I missed the number 8. Well, if that number is multiplying, that's to divide. I mean, negative 3.81 meters per second divided by 8.5 seconds equals acceleration. Please, guys, at the moment, we're going to divide velocity divided by time. Please avoid the temptation to cancel the seconds. Why? Because we are dividing. I'm going to show you why we cannot cancel the seconds. We are dividing meters per second divided by seconds. Okay, remember? Oh, sorry, I'm going to move this one. Qué bonito, es lo que me gusta que se puede mover. Okay, below the seconds, we have a number 1 imaginary number. Remember, this is a division of fractions. To divide fractions, we have to multiply the extreme with the extreme. That will be numerator, and the denominator, the middle, with the middle. Okay, meter times 1, that will be meters. Over seconds times seconds will be second square. Okay, that's why we cannot cancel the seconds every time they're going to divide velocity divided by the period of time. And if you check your notes, the unit of the acceleration in the international system is meters per second square, and the British system is feet per second square. Well, this equation divided by 8.5, the answer will be negative 0.45 meters per second square. And this is going to be the acceleration. Chon, 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 chon. Questions? Questions? And just to explain you a few minutes ago, remember when we have a decreasement on the velocity, if you see initial velocity 6.61 and final velocity 2.8 meters per second is a decrease of velocity. For that reason, the acceleration must be negative because we're braking down slowly down the car. For that reason, we have a negative answer of the acceleration. As soon as you can see, guys, the physics, the theoretical parts accomplished with the math, the mathematician part.
Mister,
Mhm.
could you explain again why it like
Mhm.
it results in meters per second squared,
Okay,
please?
see the units. Meters per second divided by seconds. Meters per second divided by seconds. Remember, this is a division of fractions. At the end, we can imagine meters per second is a fraction, and the letter S is like a whole number. Will be 1, 2, 3, so on, okay? every time they're going to divide a fraction divided by a whole number, we're going to add a denominator imaginary number 1. Okay, so we have this fraction. And we can apply the cross multiplication or the ear technique. String multiplying with the string, we're going to get the numerator, and the denominators will be the meters. Meters, seconds times seconds, and we've got second square. Or if you want to visualize in this way, there's another way of saying meters per second divided by seconds. Okay? Remember, we got the imaginary number 1 in fractions. Remember, if we really want to apply the division of fraction, we can transform this division in a product. Okay, how can we do that? Applying that reciprocal value. Meters per second divided by the unit over second. Oh, sorry, this is not dividing. This is going to be multiplying. And how we can multiply in fractions? Numerator with numerator and denominator with denominator. Meters times 1 will be meters, and second times second, second square. This is another way of doing it. Understood?
Yes,
Understood?
mister, thank you.
Okay, my pleasure. Or if you wish, if you don't want to change the position of the variables, meters per second divided by second over 1. Okay, oh, I'm going to move that whiteboard. Este es lo bonito, qué bonito. Okay, remember, we can apply cross multiplication, just like this one. Meters times 1 and seconds times seconds. Meters times 1, that will be meters. And seconds times seconds will be second square. And that's why. Got it?
Mr. Class is over.
Yeah, I know. So I have a question for you. Did you copy that already? Let's see. ¿Está bien ahí o lo dejo donde estaba? Bueno, los que ya terminaron de copiar pueden retirarse. No me queda más que agradecerles su asistencia y los espero el día de mañana. Vamos a resolver otros ejercicios. Y los que todavía no han terminado de copiar, pues los espero un ratito. Ok. Bye bye. So long. Take care of yourself.
Bye, mister.
Bye,
Bye bye.
mister.
Bye bye.
Mister, are you going to send a screenshot of the whole whiteboard?
Mire, me gustaría hacer eso, pero lamentablemente no traje mi equipo. Estoy usando el del colegio y por esa razón no le puedo tomar un screenshot porque es equipo del colegio. Pero ya mañana me vengo preparado. Si gusta, no se preocupe, yo le espero. No le voy a cerrar la sesión. ¿Ocupa que le haga un Zoom?
Solo quisiera copiar las fórmulas de Unit Acceleration.
Ah, ya.
No, esos.
Ah, ok, perfecto.
Solo les voy a tomar fotos si quieren.
Sí, no se preocupe.
Ahí, ok.
Es todo el Zoom. Por
Ok.
cierto, ¿es legible la pizarra, María? ¿Se puede leer?
Sí, es leíble, mister, se ve clarito.
Ah, ok, excelente. Yo siento como que con el celular se miraba un poquito más claro, me parece.
Cuando se le toma foto, como mister.
O sea, en la grabación en vivo, no lo nota la diferencia.
No, pero sí se mira claro.
Ah,
Siempre.
ok, perfecto.
Sí.
Si Dios lo permite, esta tarde yo les estoy mandando ya el link de las clases, tanto de física como de geometría. Ahí va a comparar usted. Bueno, al menos esta no le prometo, a no ser de que YouTube me salga otra vez con que su límite de grabación de subir videos ha excedido. Espere 24 horas. Con eso me salieron. Por eso que no los pude subir todos. Entonces voy a terminar. Por eso le digo, voy a terminar de subir los 2 vídeos de Geometry de la semana pasada que me hicieron falta, los 3 de Physics y ver si puedo subir este de Physics también.
Bueno, está bien. Entonces solo le voy a tomar una foto para no atrasar el tiempo.
No hay retraso, sí, ya más bien esta es mi última clase por hoy.
Bueno, está
Ya
bien.
te reviré, aleluya. Es el único día de la semana que tengo libertad, ya día, ¿no?
De ahí todos los días le toca clases en
Sí,
los últimos periodos.
sí, de hecho, mi última clase todos los días, a excepción de hoy, es a la 1:10. Ahí termino. Ahí sí termino de martes a viernes. Solo lunes que termino ahorita a las 12.
Bueno.
Ujú,
Misa, pero estas fórmulas tienen
ujú.
o sea, nombres, o digamos la primera es para distance, ¿verdad?
Sí, y las otras dos
Y
para velocidad final o rapidez final.
entonces
Pero,
las primeras dos son para distance, las primeras
correcto,
dos.
correcto.
Ok.
Y claro, eso no quiere decir, como usted pudo ver, de que no se pueda manipular al momento de despejar, ¿verdad? Ahora, estas 4 se llaman ecuaciones de aceleración uniforme.
Ujú.
Uniform Acceleration Equation. Es que en la clase, 2 clases anteriores, creo que fue la del martes pasado, la primera yo les introduje todo esto y estas formulitas ya se las había dado a ustedes. Es en la primera clase.
Entonces seguro las copié, Misa,
Sí,
porque las
revísela ¿cuánto fue que cayó 31?
el
El martes,
lunes,
¿verdad?
creo.
No, no fue martes.
Sí, el martes, creo, sí.
Revíselo. Estoy seguro que ya las tenía.
Mm, no, pero creo que, no, pero yo me acuerdo que sí las, o sea, usted las tenía, pero fijo le tomé una foto porque aquí no las copié,
Ya.
pero
Bueno, pero no
sí le tomé
importa.
una foto, seguro.
Bueno,
Solo
pero no
tengo las de
importa.
average speed, todas.
Bueno, pero no se preocupe, al final siempre yo le voy a subir el video. Ok, María
Ok.
Fernanda, ¿le tomo foto?
Ya solo me falta copiar la última.
Dale pues, no se preocupe, cualquier cosa me avisa. Me avisa, la lana.
Ok,
Ay,
ya,
ay, ay. Ok, bueno, María Fernanda, Dios la bendiga, la guarde y la cuide. La
igual,
veo
muchas
mañana.
gracias.
Igual,
Ok,
hija,
que pase un buen
bendiciones.
día y bendiciones.
Igual, hija,
Adiós.
bendiciones. Bye.